Hello, and welcome to Hussmann's Tech Talk podcast series. Today, we're going to be focusing on the preventative maintenance needed for air-cooled condensers on refrigeration systems, and specifically, we're going to be looking at some of their mechanical failures. Now, if we look back to our first podcast, we focused on cleaning procedures for air-cooled condensers, and be sure to check that one out. My name is Paul Nedeau, and I'll be your host along with our resident expert, Don Elliott. Hi, Don.
Hi, Paul.
Don, we've got several questions for you about air-cooled condensers, the preventative maintenance, and here's our first one. On the first podcast, we determined that dirt and debris was one of the biggest issues when it comes to this lack of airflow. So let's talk more about that and about mechanical failures behind that lack of airflow.
Paul, you're correct. Mechanical failures can be just as disrupting. Lack of airflow can be caused by fan motor failure. Larger air-cooled condensers are usually direct drive, but the other systems to look for is a V-belt, end pulley, or otherwise known as a shiv system. For this podcast, we'll be referring to it as a pulley system. On this system, the fan blade shaft is driven by a bearing and pulley system. The motor has a pulley as well. Both pulleys are connected by a common V-belt. With this system, a broken V-belt will cause the fan blade to stop running. Failed bearings can cut into the fan blade shaft and stop the fan blade from turning as well. Fan motor cradle brackets can also break and cause the fan motor to tip and cut into the fin and tube condenser and cause major damage.
Don, is there anything else that would help us know more about these types of issues?
Yes, larger air-cooled condensers commonly use three-phase motors to drive the fan blades. If the motor loses one of the three phases of electricity, the motor could stop spinning or spin backward, disrupting airflow throughout the condenser. If the three-phase power is not connected properly, the motor will turn the wrong direction. This can easily be corrected by switching two of the three phases of power. Failed three-pole contactor can cause problems as well. Paul, a technician has a 50-50 chance at getting this correct without using a phase sequence meter.
Well, Don, that doesn't sound like great odds to me. What else can be done so a technician can prevent this lack of airflow mechanical issue and failure?
Paul, again, starts with a good preventative maintenance program. Fan motors on most self-contained condensers are fractional horsepower. They're shaded pole, permanent split capacitor, or ECM type motors. These motors are typically hermetically sealed and replaced when failed. Fan blade cleanliness is important as well. Just a thin layer of dust on the leading edge of a fan blade can decrease airflow and efficiency.
Okay, Don, well, that sounds really good for those smaller interior self-contained equipment and units, but what about the larger exterior HVAC and refrigeration rooftop condensers? Can you tell us a little bit more about those equipment and their preventative maintenance and repairs?
Sure, Paul. Let's start with condensers that use V-belt drives for fans. They will need a V-belt inspection and possible replacement. It is important to use manufacturer's recommended V-belt size. When replacing worn or broken V-belts, it's important to inspect belt tension and alignment. I would recommend checking out Browning's V-belt training on their YouTube page. There you'll find more details on V-belt tension and alignment. It's also important to inspect the pulleys for wear and grooves. If the replacement is needed, make sure the pulley is replaced with the same size. A change in diameter is going to be a change in fan speed and CFM. And remember, never try to change a V-belt on energized or running equipment.
Don, that sounds like really good advice, especially from a safety perspective. So please always follow proper lockout, tagout safety procedures and wear your PPE when working with this type of equipment. And of course, always read the manufacturer's instructions depending on the type of equipment that you're working on. So Don, let's talk for a moment just about bearing inspection and tell us a little bit about that and why that's so important.
Paul, bearings on the fan shaft will need to be inspected. Grab the fan shaft, move it back and forth, and check for play in the bearings. If the fan shaft moves back and forth, this is an indication that the bearings will need to be replaced. Some bearings come with a grease zerk. Be careful not to overgrease the bearings. The seal in that bearing will tear and the dirt will get in and cause premature bearing failure.
Well, Don, it sounds like grease could be too much of a good thing, right?
Yeah.
Absolutely. So be careful about that. So Don, what else is there to consider when working with this type of equipment?
Paul, motor mounting supports need to be inspected for cracks. In my experience, I've seen motor supports break, the fan motor can drop and cause damage to the fin and tube condenser. When checking the motor, just like the fan shaft bearing, check the motor's shaft for play. If it moves back and forth, the bearings are worn to a point where the motor needs to be replaced.
Don, that is really good advice. So tell us a little bit more about the direct drive fan motors.
Paul, condensers that use direct drive fans are a little more straightforward. Since the fan blade is mounted straight on the motor shaft, there's no other mechanical moving parts. The motor mounting cradle should be checked for cracks and vibration. Vibration is generally caused by a damaged fan blade or loose motor mounting. If the motor mounting cradle breaks, the fan and motor could fall into the fin and tube condenser, causing damage and possible cuts into the tubes, creating major refrigerant loss. I've experienced this, and it creates a huge negative impact to the customers and product.
And Don, that is really critical when you have a major refrigerant loss. So that is very important. So thank you for pointing that out. So Don, as we kind of get ready to wrap up, is there anything else that we should know about when working with this type of equipment with air-cooled condensers?
Paul, I would like to add, a technician should never stand or set heavy motors directly on the condenser fins. This is damaging. This will cause the fins to bend and potentially block airflow. And always inspect fan blades for cracks and corrosion.
Don, thank you so much for sharing that great advice. And we would like to encourage everybody out there to always use your PPE and proper lockout, tagout safety procedures. And as always, read all safety and product information before servicing any of those types of equipments. So this concludes this Tech Talk podcast focusing on air-cooled condensers and their mechanical failures. Thanks for listening. We really appreciate it. And we look forward to you joining us on our next Tech Talk podcast series. Thank you.